Hey guys, welcome back to Deco 3100. This week we're diving deeper into Plotly.js, learning how we can create more dynamic plots to really tell our stories in an interactive way. Before we jump into interactions and animations, I want to quickly talk to you about one specific type of plot that we can create using Plotly, and that is maps. I don't think I need to explain to you too much about why maps can be useful for data visualization, and you can always go back to Kaz's lecture from week 4 to explain some of the different types of maps that we see out in the world. This is a particular map visualization that I saw the other day that tells a really interesting story, and there's a few things in this map that we're going to unpack in today's tutorial. So you can see the story that this map is telling us is the search trends around the world during COVID-19. We saw originally people initially started to search for symptoms, especially during the outbreak period of COVID-19. And slowly that trend changes as people start to search for restrictions and then eventually testing and the vaccine. This is an example of a choropleth type visualization where areas of our map are separated based on geographical boundaries, and in this case color is used to represent different data points within those boundaries. We've also got animation as this map changes over time and people search for different search terms, which are shown in the bottom in the legend. And we also have annotations, which is giving us a little bit more information about the story. To make a choropleth in Plotly, it's quite simple if you have a good data set. This is the result of a plot showing us the global GDP around the world based on some data from the CIA World Factbook. And you can see that the scale of the color represents a higher amount in GDP as we saturate that blue. You can see that you hover over countries to find out individual data points where the color itself just gives you a rough indication, making it easier to compare across countries. If we take a look at the JavaScript, we can see that we are using a CSV import, and if you were to go and open that CSV, you would see a fairly simple set of data. And the main thing in that CSV is the country code, which allows us to use the different areas on the map to represent the different data, in this case, the GDP. So when it comes to building our data object or our data array, we use the type choropleth, and we have this new property called locations. Locations is the main property that we need to use to tie our data to the map. In this case, we're using a country code, which is a 3-character code that represents each country uniquely. We then have the z-axis, and in this case, the z-axis is referring to the GDP value. We also have a text property, and the text property gets attached to each country, and that's what we're seeing when we hover over. So we see the actual data point itself. In this case, for the United States, that's 17.42 thousand, and the text value is the country itself, so the United States. This is different from the country code, which is in the locations property, and this is purely meant to be read by humans. We can also see that we've got the color scale property where we've defined a custom color scale, although there are plenty of color scales that I mentioned in my previous tutorial that you can use from Plotly. Those are the main things that we need to set up in order to use our choropleth style visualization. But we can also see in the layout, there's a few properties we can change under the geo property, which will then change the way our map gets displayed. Firstly, we've got show frame. That's to show the outer frame of the map. Show coastlines will then show each individual coastline of the continents. And then the projection property has a sub-property of type. In this case, we're using the Mercator projection, but there are a lot of other ones out there that I would encourage you to go and explore. We don't have enough time in this tutorial to go through all of them, so I'll leave that up to you. Choropleths aren't the only types of visualization we can do in Plotly using maps. Another type we can do is line visualizations on top of maps. In this case, our lines are representing American airline flight paths from February 2011. And if we take a look at the JavaScript for this, we can see that it's a fairly different setup in order to get our lines showing on our map. The type of visualization that we're going to be using here is the scatter geotype. And that is like a scatter plot, but on top of some geospatial data. And in exactly the same way that we can use scatter plots to create line charts, we can use scatter geoplots to create lined maps. The location mode property only has a few possible variables that we can use for the values. USA states is one, but that's obviously very USA centric. Another location mode we can use is country-names for when you're having a world map that you need locations on. And then lastly, ISO-3, which is the technical name for the standard of country codes that I mentioned in the last slide. We can also see that we have the lon value, short for longitude, and the lat value, short for latitude. In this case, because we're trying to plot lines on the map, we need a start and end value for both of those properties. We store those in another array, and so this ends up being an array with a value that's getting pulled out of our CSV. This is all based on a for loop, which is counting the number of rows and then iterating them in order to build our data object. So unfortunately, with Plotly being American-centric, a lot of the examples that you'll see in the documentation are all based around the US. So let's look at something that might be a little bit more relevant to us. This is a map that I created that shows the average beer prices around Australia. This is another scatter plot, but in this case, we don't want destinations to and from, we just want a single location. And so we use points to represent that on the map. The points themselves are also representing more data, which is the beer price itself. I've made a color scale here from light yellow through to dark red. That's using one of the built-in color scales on Plotly in order to show us the relative prices between different cities in Australia. As you hover over those points, we can see some extra details such as the city itself, the price of the beers in that city according to an average of a sample of people that have submitted prices, and then the longitude and latitude coordinates as well. If we pop open the JavaScript for this visualization, we can see that again in our data model, we're using the type scatter geo. We're providing the longitude and latitude, this time directly from our CSV rather than filtering it through another for loop and combining it with a start and end value. And then we have a few more properties, and I'll come back and talk about these later. If we scroll down to the layout, we can see that we again are using that geo property, and we've got a couple of different properties within that geo property that I want to tell you about. Firstly, we have the scope. This is going to set the extent of the map that you see in Plotly. There's a few different values that you can put here, ranging from the US to Europe, Asia, but unfortunately there's not a value that we can use for Australia specifically. So in this case, we use the world map, and rather than display the whole map from the beginning, I'm using the lon axis and the lat axis properties in order to restrict the range of our plot to just the boundaries around Australia. And I had to figure those out manually, but with a little bit of guess and check, you can work out what they are. This is just like we would set up the range properties for our other plots, such as a line graph or a scatter plot, where we want to limit the range of that axis to a certain value. The projection type that we're using in this case is equirectangular, which is, imagine if you unfold the globe onto a sheet of paper. So a 2D projection of the full globe in a rectangle. There's also a few properties that you can use to change the style of the country boundaries, such as the color of the land, the color of the countries, and then some of the subunits if you have geographical boundaries such as states, territories, or counties. I want to quickly mention Mapbox because this is something that you'll see if you go and take a look at the Plotly documentation. Mapbox is a service provider for tiled maps, very similar to Google Maps, but Mapbox is a slightly more open data source than Google Maps. And there's a few situations where you might want to use Mapbox. For one, it handles large tile sets a lot better than the default map visualizations in Plotly. So if you want the user to really be able to zoom in to a street level and pan around the whole world, Mapbox is going to be a lot better at loading those tiles progressively as the user interacts with your map. And because Mapbox is built on the OpenGL framework, which is a graphics library for the web browser, you can get a little bit more advanced with the type of visualizations you are doing on your maps. Again, unfortunately, there's not enough time in this tutorial to really dig deep into Mapbox, so I'll leave that up to you to go and determine if that's something you want to use. Just be aware that if you are using Mapbox, there's a bit of extra setup involved where you have to get an API key from Mapbox in order to use their service. So enough speaking from me for now. It's your turn to go and make a map visualization of your own. I've provided a CSV here that's linked to a GitHub file. And I want you to try to plot all of the locations from that CSV, which represent the government-owned land in Australia, using the latitude and longitude values. I'll let you work out what type of map you need in order to make this plot. As a bonus challenge, see if you can find any suspicious places that the government owns that maybe are a little bit strange. What are they doing there? Are they hiding something? I'll leave that up to you.